Hello and welcome to the channel. In today's video, we will be solving some past paper questions of the topic physical quantities. As you know, we have thoroughly covered the topic in our last two videos. So before starting with the questions, you might want to check them out first to get a hang of the topic. Every time a question appears, try pausing the video and solving by yourself first and then following along with my explanation to see if you have done it correctly or not. So let's begin. So this is our first question and it's from summer 2018, question paper 1, variant 2 and question 4. So you can pause the video at this point and try doing it by yourself first and then we will discuss the answers. So the question states, micrometers, meter rules, tapes and calipers are used for measuring lengths. Which row identifies the most suitable device for accurately measuring the stated length? So they have given us lengths and we need to tell that which instrument would be the best to measure that length. And actually this type of questions are very common these days. Often question 1 or question 2 is related to lengths and the correct instruments for measuring them. So make sure you get a hang of this and know it perfectly, and then you would always be able to do this question without any trouble at all. So let's go through the options that they have given us. The first option is the length 0.15 millimeter. And the device they are using to measure it is a micrometer. Now we know that a micrometer can measure up to 0.01 millimeter. In fact, it is the only instrument that can measure up to 0.01 millimeter, because even a vernier caliper only measures to 0.1 millimeter. We have already done the least counts. So the length 0.15 millimeter can in fact be measured by a micrometer, and no other instrument except a micrometer would be able to measure it, because 0.15 millimeter is so small that even a vernier caliper would only give us 0.1 millimeter, it would not give us 0.15. So indeed, A is the correct option, because 0.15 millimeter can be measured by a micrometer only. But let's also discuss the other options and see why they are not correct. So our second option is 0.50 millimeter, and the device we are using to measure it is a meter rule. Now we know that a meter rule has a least count of 1 centimeter. What this means is that any length that is below 1 centimeter, it cannot measure it. And as we know, 0.50 millimeter is less than a centimeter, so a meter rule cannot be used to measure 0.50 millimeters. Now the third option is 0.15 meter, and the measuring device we are using is a tape. Now the thing about a measuring tape is that we only use it to measure quantity lengths that are bigger than 1 meter. For any length that is smaller than 1 meter, we either use the meter rule or we use the vernier caliper and micrometer, depending on the accuracy that we need. There is one certain scenario in which we use a tape for smaller lengths too, but we will cover that later. So also, a measuring tape usually gives our readings in inches. It usually either gives in fits or inches, whereas 0.15 millimeter actually means 15 centimeter. If we convert it into centimeters, 0.15 meter becomes 15 centimeter. So 15 centimeter is far too small a reading for us to use a measuring tape for it, so C is also incorrect. Lastly, our length that they have given us in option D is 0.50 meters, and the measuring device is vernier caliper. Now the problem here is that 0.50 meter, first let's convert it into centimeter, because we know the maximum value that vernier caliper can measure is either 20 or 30 centimeter. Any value that is above 20 or 30 centimeters, a vernier caliper cannot measure it, whereas 0.50 meters is actually 50 centimeters. So a vernier caliper cannot extend, its jaws cannot extend that far to measure anything that is 50 centimeters. So again, option D is also incorrect. So the only option that is correct was option A, 0.15 millimeters, which can be measured only using a micrometer. Let's move on to the next question. A student wishes, you can pause the video here and figure out the answers, and then we will discuss again as usual. So this question is from summer 2018 again. Question 1, variant 1, question 2, question paper 1 and variant 1. A student wishes to measure directly the circumference of a football. Which is the most suitable instrument to use? Now, this is a trick question, and also the reason why I included it in this practice question exercise was because in this question we have to consider something very important, and that is that we are measuring the circumference of a football. Now, the reason why this is very important is that the circumference is a curved surface. It's not flat, right? The circumference is round. It's a football is a rounded substance, right? So the circumference is also curved. It's not flat. Now, vernier caliper, measuring tape, and micrometer, they are all instruments that are only used to measure flat lengths. You cannot bend a ruler, right? If you bend a ruler, it will break. So the only thing that, yeah, a ruler and measuring tape and micrometer, they are all not bendable. They are all inflexible. So they are only used to measure straight or flat surfaces. Whereas a tape, as you know, it can be bent. It's not like a very hard substance. You can bend it and it will not break. So whenever we have to measure a curved surface like the circumference of football or the circumference of any smaller object or any bigger object, say the dome or the shape of the dome of masjid or something, in certain cases like that, we always use a ruler, a measuring tape, because that is the only measuring instrument that we can use to bend it. And obviously when we have to measure the circumference, we would have to bend the tape so that it covers exactly the entire circumference of the football. So the answer for this is a measuring tape, because we need to be able to bend it. Now move on to the next question. Again, pause the video if you want, and then we will discuss the answers. So this question is from summer 2005, question 1, question paper 1, and there didn't used to be variants back then, so it's just variant 1. So which instrument is used to measure the internal diameter of a pipe with a single measurement? This again is sort of a trick question, and this is also the reason why I included 3 measuring questions in our practice exercises. This is the last one, by the way, for this certain topic. So the internal diameter of a pipe with a single measurement. The word to notice here is internal, and this is important because usually when we have to measure something such as small as the diameter of a pipe, we in most cases use a micrometer because it gives more accuracy. But the problem is that a micrometer has only one set of jaws, so it only measures external lengths. It never measures internal lengths. Whenever we have to measure internal lengths, we cannot use a micrometer. Whereas a vernier caliper, as we have studied, has 2 sets of jaws. It has both external jaws and internal jaws. So here in this question, they are telling us to measure the internal diameter, and for that we have to use a vernier caliper because only that instrument would give us the reading of the internal diameter. If we had used a micrometer instead, it would have given us the external diameter of the pipe, which is not what they are asking here. Obviously, measuring manometer is a pressure device, and that's completely different. Measuring cylinder, which is option B, is used for measuring the volume, so it does not have anything to do with length. So the answers could either have been C or D, because both micrometer and vernier calipers are used to measure length. But as we have learned now, that micrometers cannot be used to measure the internal diameter, so our answer becomes D, vernier caliper. Let's move on to the next question. The correct answer is D, obviously. So here we have a vernier caliper reading question. And nowadays these questions are not very common. You won't really find them in any recent paper, but it still is good for us to be prepared for them just in case they come. So this paper is quite old, as you can see. It's from winter 2005, question paper 1, question 1. So they are asking us to find the correct reading that is given. Now in this question, by the way, they have given the vernier scale above because it is labeled V, right? Actually, let me turn on my mouse pointers for this, which will help us understand it much easier. So yeah, I've got the laser pointer on now, as you can see. I hope you can see it on the screen. So the vernier scale V is actually the one that is on top. Usually the vernier scale is on bottom, but that doesn't matter as long as we know the correct idea. Now we have done an in-depth video of how to take readings, so I'm not going to go too deep into it. We are just going to see the major points and focus on that. So the main scale is on the bottom and the vernier scale is on the top. V is on the top, as you can see here. There's also one more thing to notice here, and that is that they have not given us the unit of the main scale. Usually the unit is written here, but they have not given us the unit. But that doesn't matter, because in the options we see that even the options do not have the unit. So we are not concerned with the unit at all in this question. So as we know that first we have to take the main scale reading, and the way to take the main scale reading is that we see where the 0 is of the vernier scale, and then we take the biggest reading that comes before the 0. So as you can see that between 2 and 3 there are 10 divisions. So all of these divisions must mean 0.1. So this becomes 2.1, 2.2, 2.3, 2.4, 2.5 and so on. So all of these mean 0.1. So the biggest division that comes before the 0 on this side is this one, right? And when we see which one this is 2.1, this is 2.2, this is 2.3. So our main scale reading becomes 2.3. Now let's move on to the vernier scale reading. The vernier scale reading is the one that forms a straight line with the main scale, as I hope you guys remember. This one does not, nor does this one. This one again is slightly not forming a straight line. As you can see, this reading is a bit before the vernier scale reading. However, look at this one. This forms a perfectly straight line, and so this is our vernier scale reading. Now which one exactly is this? This is 0, so this is 1, 2 and 3. So our vernier scale reading is 3. But as we know, we put a point 0 before a 0 and a point and another 0 before the vernier scale reading, as we learned in the last video. So 3 becomes 0.03. We put a 0 before it and also a decimal point. So 3 becomes 0.03. Now we just need to add these two together. 2.3 plus 0.03 makes 2.33. So our correct answer becomes C, 2.33. Let's move to the next question. A quantity is quoted as having a value of 6.2 ms. In which units is it measured? This question is, by the way, from winter 2011, question paper 1, variant 2, question 7. So a quantity is quoted as having a value of 6.2 ms. In which units is it measured? So we need to tell what ms represents here. Now the first option they have given us is meters. As we know, the SI unit of meters is a simple m, a small m. So ms cannot mean meters only. It could have mean meters and then something else, but simply if it was simply meters, it would just have been 6.2 m, not 6.2 ms. Next, they have given us meters per second. Whenever we say per, it means there's this quantity is being divided by this quantity. So meters slash second, it would have been meters slash second if it was meters per second, because slash means division, right? So meters divided by seconds is what is meant by meters per second. Whereas here these two quantities are being multiplied. They don't have a division sign in between them, so they are being multiplied. So this cannot also mean meters per second. Third option is microseconds. Now this kind of makes sense because seconds can be represented by s, as small as usually means second. But the problem is the unit for micro, as we learned, is a Greek letter that resembles U. I hope you guys remember that. It's sort of a weird U-shaped, reverse U-shaped symbol. So micro is not represented by a small m, so again microseconds is also wrong. That leaves us with the fourth option, which is a millisecond. And that is indeed the correct option, because milli is represented by a small m and seconds is represented by a s. And there is no milli per second, so there shouldn't have been a slash between them. So milliseconds is what is meant by ms, because ms represents milliseconds. So our whole quantity becomes 6.2 milliseconds. So our correct answer is D. Now for this question, this is from summer 2005, question 5, question paper 1, and back then there didn't used to be any variants, so it's just variant 1. So again, you can pause the video here and try to solve it by yourself, and then you'll discuss it. So question 9 is, which is the correct statement about force and velocity? Our first option is force and velocity are both scalars. Option 2 is force and velocity are both vectors. C is force is a vector, velocity is force is a scalar, velocity is a vector, and option D is force is a vector, velocity is a scalar. Now this is a pretty easy question, as I hope you all know that we have thoroughly covered both scalar and vector quantities. So we know that both force and velocity have a magnitude obviously, and they both also have a direction, because that's what distinguishes speed and velocity. Velocity has direction. So both force and velocity have both a magnitude and a direction, and that means that both of them are vectors. So our correct option becomes B. Force and velocity are both vectors. Moving on to the next and final question for the day, we have this question from Winter 2011, question 7, question paper 1 and variant 2. Now, this question says each row contains a vector and a scalar. In which row is the size of the vector equal to the size of the scalar? Now, a short revision, we know that a vector quantity has both a magnitude as well as a direction, whereas a scalar quantity only has a direction, or only has a magnitude, sorry. So, by the way, the word size means the same as the magnitude. So, if you say the size of a vector, it means the magnitude of the vector. We use the word size and magnitude interchangeably, so they mean the same thing. So in this question, what they're trying to say is that they want us to tell them that which vector has the same magnitude as the magnitude of the scalar. We are not concerned with the direction at all in this question. We are only talking about the size of the vector, that is the magnitude of the vector, and the magnitude of the scalar. A scalar only has a magnitude, so obviously we can only talk about the magnitude. Now, the first option they have given us is displacement of a car, and the scalar is speed of the car. Option B is velocity of a car and distance traveled by the car. Option C is velocity of a car and the speed of the car. And option D is weight of a car and the mass of the car. So we need to tell that which two magnitudes are the same. Let's talk about option A, displacement of a car and speed of the car. We know that displacement is the actual distance that is traveled by a car, and it is not dependent on the speed, because we could be traveling at 2 meter per second speed for 60 hours, or we could be traveling at it for 2 seconds, and in both the cases the displacement would be completely different. So the magnitude of the displacement is not necessarily to be equal with the speed. It would almost never be equal to the speed, because there are so many scenarios in which they would be different. So the option cannot be A, because their magnitudes are very different. So our option B is velocity of a car and distance traveled by the car. Again, the distance traveled, although it is related to the velocity, how fast we are traveling would tell how much distance we are traveling, but the time here again has a huge role. We do not know how long we have been traveling at that velocity. If we have been traveling at the velocity for a very long time, the distance would be very high, or else it would be very low. So in most circumstances, the distance traveled would again not equal the velocity of a car. Let's look at the third option, velocity of a car and the speed of the car. Now we know that the velocity is basically the speed plus a direction, because velocity is a vector quantity, it must have a direction, right? So velocity just tells how fast an object is moving and in which direction it is moving, whereas speed only tells how fast the object is moving. But as we are not concerned with direction, when we are not talking about the direction, velocity and the speed both have the same magnitude, because they are both telling how fast the object is traveling. So the size of the vector here, which is velocity, would indeed be equal to the size of the scalar, which is the speed. Because if an object is traveling at 5 meter per second, both the speed would be 5 meter per second and the velocity would be 5 meter per second plus a direction. But as we are not concerned with the direction, C becomes the correct answer, because the magnitude is indeed the same. And that is what they are essentially asking in the question. But let's also talk about option C. Weight of a car plus mass of a car is equals to mass of the car. That is not usually correct, because see, the weight is basically the mass multiplied by gravitational field, right? And in normal circumstances, like on the earth or on the moon, the weight would be greater than the mass, because we are multiplying the mass with the gravitational field, which is more than 1. And even if we are in a vacuum, in that case the gravitational field will be 0. So even in that case the weight would become 0, because anything multiplied by 0 essentially becomes 0, right? So in almost no circumstances would the weight of a car be equal to the mass of the car. So this option is also incorrect, and the only correct option that we had was C, velocity of a car. The magnitude of the velocity of a car equals the speed of the car. Well, this is it for this video. Stay tuned for further topics. We would soon be beginning with the second topic of our physics, that is Newton laws and forces. So stay tuned for that, and have a great rest of the afternoon. Thank you.